Hi guys, welcome to the notes for concept 3. Let me switch the color here. So this is concept 3. You're going to go ahead and put this in your notebook on page 11. So that will be where you're at. So for solving equations, we're going to solve a bunch of different kinds of equations. But for right now, what we need to know is that what we have been working with is called expressions. Right, so that's what we see here in this first box. And then the difference over here is that this one is called an equation. Right? So the question says, how are these the same and how are they different? Take a second right now to write down how they're the same and how they're different. One way that you might have said that they were the same was they have the same numbers. So the same numbers. They also have the same plus sign. And then one way that you might have seen that they're different is that the second one, the equation, has an equal sign. Right, so this equal sign right here is what makes that an equation. If it's just a bunch of numbers and letters put together, then that's what's called an expression. So we'll see those play out multiple ways throughout our thing here. So it says, write an algebraic sentence to represent each verbal sentence. So they're going to give us a verbal sentence. That's what this is right here. And they're going to ask us to write an algebraic sentence. So the algebraic sentence is like... it's like an expression or an equation. So it'll be an expression or an equation based on what we see. So I'm just going to start from the beginning and see what I can do. So 2 more than. So 2, and when we see more than, I know that that's an addition sign. Sometimes we might know that it's more than, or it could be an addition sign. We have to read for the context of the problem to find out. So 2, actually let's back that up. In general, if we know that we're looking for this, if it says is more than. Is more than tells me that it's like an equal sign, but instead it's an inequality. If we just see more than, we're going to know that it's an addition sign. So I have 2 more than 4 times the cube. I know that a cube means to the power of 3 of some number. So I don't know what that number is. You might use x, you might use y, you might use k. I'm going to use x in this case. All right, so what this is saying is I'm taking the cube of a number, right? So that's x to the third times 4, and then I'm adding 2 to it. Another way I might write this is 2 plus 4x to the third. I don't need that multiplication sign because it is implied when we have 2 numbers next to each other. So the 4 and the x when they're together. All right, go ahead and try number 2 on your own, and then let me know what you get. All right, here it says the quotient. So I know that that means division. So I know there's going to be some dividing here. I'm going to use the fraction bar. You could use the division sign if you want, but it's a little bit like 4th grade. So we're going to use the fraction bar. So it says the quotient of 5 less than. Again, if it says is less than, that could be this guy. But because it just says less than, I know that it's minus. So 5 less than, I'm going to have less than 5. A number, so some number. I'll use y in this case. And 12. So what this is saying is I have the quotient of 5 less than a number. So I'm going to back up here so we can really see what's going on here. So the quotient of, so that's telling me what is being divided, and then it's going to tell me the 2 things being divided. 5 less than a number, right, and 12. So if I'm thinking about this in pieces, I see the quotient of, the quotient of an and. Those things are going to go together. And then I have my first part, which is 5 less than a number. and my second part, which is 12. Right, so that tells me the where the division sign goes, what goes on top, and what goes on bottom. Right? So that's writing an algebraic sentence to represent the verbal sentence. Now we're going to work backwards for numbers 3 and 4. So it says write a verbal sentence in order to represent each equation. So in this one, I see that 6 is being multiplied times x. So I could say 6 times x is, that's my equal sign here, 72. Another way you might write it, something that means times, is the word the product. So I could say the product of 6 and x is 72. It's exactly the same. Either of those could work. Go ahead and try number 4 on your own. See if you can write it in 2 different ways. Okay. I have a number, in this case it's n, plus 15 is 91. You could also say the sum, because the word sum means the answer to an addition problem. The sum of a number and 15, so I'm adding a number and 15, is 91. Right? So we're just working in a backwards way this time. Awesome. So that's going to be how we write things, write expressions and equations using words. Right? And now we're going to jump into the quick gist of solving them. So you've seen these like forever. You've seen them since first grade. So we're going to pop them in. We see here in 2 instances something that might be a little tricky. One is a decimal, and then one is a fraction. So what I see in this first one is I'm going to ask myself, what do I see in this equation? What I see in this equation is this subtraction sign. In order to solve an equation, I need to do the opposite. The opposite of subtraction is addition. So I'm going to add 3.24 underneath here. And what I do to one side of the equation, if you think about this like this, what I do to one side of the equation, I also have to do to the other side of the equation. And I'll line up those decimal points so I can add them. Here I have n. This becomes 0, right? So that's going to go away. And then I have my 4 comes straight down. 1 plus 2 is 3. 2 plus 3 is 5. And 45. So I know that in this case, n equals 45.34. All right. For the second one, there are sort of 2 ways you can do this. I'll try both of them. So if you see that you have a fraction, you can start by getting rid of the thing that's on the bottom. So what I see is division. The opposite of division is multiplication. So I see divide by 8. So I'm going to multiply by 8. What I do to one side, I have to do to the other. That's going to allow 8 divided by 8 is 1. So I now have negative 5x equals 20. So 2 times 8 is 160 with 116 with 1 0. From there, I'm going to divide by negative 5. Divide by negative 5. It's going to give me x equals, I'm going to go to my calculator, 160 divided by 5 would be negative 32. So that's one way you could do it. Right? One way you could do it, you get rid of the thing on the bottom and then you get rid of the thing on the top. The other way you might think about doing this is to get rid of both fractions, or the whole fraction at the same time. So I know that I can multiply by the opposite, what's called the reciprocal. Let's see. So I know that over here I can multiply by negative 8 over 5. And that means that I have to do to the other side as well, negative 8 over 5. So that means negative 8 and 8 cancel. 5 and 5 cancel. the negative and a negative become a positive, and all those things are canceled now, so it's just x left on this side, equals, and then my calculator, and I'm typing this in, I'm going to do 20 times negative 8 divided by 5, and I get negative 32. The exact same thing. One takes a little bit longer, but is a little more simple. Okay. The same is true when I'm solving an equation with multiple pieces. So I'm going to make things as simple as possible with each of these equations. I'm going to make them more simple, and then I'm going to get rid of them. So to make this more simple, to get rid of the parentheses, I'll distribute. I'll do the same on this side. So I have 5 times x, 5x, 5 times 3 is positive 15. On the orange one, I have 2 times 1 would be plus 2. 2 times negative x, negative 2x. On the other side of the equal sign equals 14. Right. So remember, I want to leave x's on one side of the equal sign and y's on, or numbers on the other side. Wow, sorry about that. Let's see here. So here's my equal sign here. I'm going to leave my x's on the left side, so I'm going to get rid of my y's. I'm sorry, again, my numbers. So let's see, I'm going to get rid of 15 by subtracting 15. And I'm going to get rid of 2 by subtracting 2 on both sides. It might look a little different than how you've seen it before. I just did 2 steps at one time. That's okay. If you want to combine like terms first, that's okay too. So here I have 5x minus 2x is equal to, I'm going to do this part in my calculator. I'm going to know 14 minus 15 is negative 1, minus 2 is negative 3. From here, I can combine like terms. 5x minus 2x would be 3x equals negative 3. Divide by 3 on both sides. X equals negative 1. Try to keep things as lined up as possible so I know exactly how to finish my problem. Awesome. Go ahead and take a second to work on this next one. Then come back. Awesome. Again, I'm going to simplify. So I'm going to simplify by distributing here and here. So I have the negative 10x coming straight down. 3 times 4x would be positive 12x. 3 times negative 2 would be negative 6 equals 6. All right. Again, I want to leave numbers on one side and x's on the other. So I'll leave over here the negative 10x and the positive 12x. In order to get rid of the 6, though, I'm going to add 6 to both sides. I see subtraction, so I need to use addition. So I have negative 10x plus 12x equals 12. I'll go ahead and combine like terms. Negative 10 plus 12 is 2x equals 12 divided by 2 on both sides. X equals 6.